everyone. Today, we will explore one of the most important branches of forensic science, forensic ballistics, specifically the individualizing marks found on fired bullets and cartridge cases or shells. The main goal of this presentation is demystification, to simplify and clearly explain the different marks left by the firearm on bullets and shells during the firing process. These markings, though often microscopic, are incredibly valuable in criminal investigations. Every firearm, whether newly manufactured or already worn by use, carries its own unique physical characteristics. These characteristics are transferred through bullets and cartridge cases every time a gun is fired. As a result, these marks can help identify the exact firearm used in a shooting incident. This is essential in solving crimes, linking suspects to weapons, reconstructing events, and supporting courtroom testimonies. By understanding these individualizing tool marks, both on bullets and shells, we gain deeper insight into how forensic examiners match ammunition components to a specific firearm, making ballistics a powerful tool for achieving justice. In order for us to better understand how markings appears on bullets and shells, we will be going to begin with the basic of internal ballistics. The events that happen inside the firearm the moment the trigger is pulled, the firing pin strikes the primer, igniting the gunpowder. The expanding gases push the bullet throughout the barrel where it makes contact with the rifling, the lands and the grooves that spin the bullet. As the bullet travels through the barrel, as the cartridge case expands inside the chamber, both surfaces pick up tool marks. In forensic science, tool marks refer to the unique microscopic features left on an object due to contact with another surface. Since no two firearm components are exactly the same, these tool marks become the individual characteristics that allow forensic examiners to match a bullet, and this is the scientific foundation behind every firearm's identification. This time, let's now discuss the five marks found on the fired bullets. Fired bullets carry several important markings caused by the rifling and internal surfaces of the barrel. These markings help identify the firearm used. The five major bullets marks are the following. First, the landmarks. Landmarks are the raised impressions on the bullet made by the lands of the barrel. As the bullet travels through the barrel, the raised parts press against it, leaving long, shallow marks around the bullet. Second, the groove marks. Groove marks are deeper impressions caused by the grooves of the rifling. These are the cut out portions of the barrel that give the bullet its twist. Groove marks appear as deeper, more noticeable cuts along the bullets, as you can observe in the image. Third is the slippage marks. Slippage marks occur when the bullet momentarily fails to fully grip the rifling. Instead of a clean impression, the mark looks smeared or blurred. This happens when the barrel is worn or when the bullet is too soft. Fourth, the shaving marks. Shaving marks appear when the rough or sharp edges inside the barrel scrape or shave off small portions of the bullet's surface. These marks look like small scratches, peeled areas, or straight cuts on the bullet. Lastly, the striation marks. Striations are fine microscopic scratches unique to each firearm. They are produced by the tiny imperfections inside the barrel. Striations are the most important marks because they serve as the firearm's individual signature. We are now done with the five marks on the fired bullets. Now, let's discuss the seven marks on the fired shells. Marks on the fired shells. When a cartridge case or shell is fired, it is subjected to forces inside the firearm that leave unique identifiable markings. These markings are critical in forensic investigation because they can be used to match a shell to a specific gun. There are seven main types of markings found on the fired shells, and these are the following. First, the firing pin impression. The firing pin impression is the indentation left on the primer when the firing pin strikes it to ignite the gunpowder. Its shape depends on the firearm's design and can be round, oval, or rectangular. Second, the breech face mark. Breech face marks are impressions left on the base of the cartridge case when it slams backward against the breech face of the firearm during firing. The pattern reflects the machining marks of the breech surface. As you can observe in the image provided, it is next to the firing pin impression. Third, the extractor mark. The extractor mark is produced when the extractor claw or mechanism grips the rim of the cartridge case to pull it from the chamber. It appears as small scripts or indentation on the rim. It is very visible in the image provided. Fourth, the shear mark. Shear marks occur when the extractor slips or partially cuts into the rim while pulling the cartridge. They usually appear as shaved off or partially cut sections on the rim. Fifth is the ejector mark. Ejector mark is caused when the cartridge case strikes the ejector mechanism as it expelled from the firearm. This leaves a flat dent or scratch, often opposite the extractor mark. Sixth is the chamber mark. Chamber marks are created as the brass case expands tightly against the chamber walls under high pressure. This contact produces fine parallel scratches along the case body. Lastly, the magazine lip mark. The magazine lip mark are formed when the cartridge is guided upward by the magazine lips before entering the chamber. The contact leaves small scratches or impression on the top sides of the case. In order for us to better visualize it, I provided this picture. You can easily watch where is the firing pin impression, the ejector mark, the breech face mark, and the extractor mark, and so on and so forth. Through this image, we can distinctly and identify which part of the cartridge case or bullets found these marks or impressions. We are now done discussing the 7 marks found on the fired shells. Now, this moment, let's discuss the comparison microscope and what is the importance of this one in forensic ballistics. So, once a bullet and shells are recovered from a crime scene, forensic examiners use forensic comparison techniques to determine if they were fired from the specific firearm. The most important tool for this task is the comparison microscope. A comparison microscope is essentially two microscopes joined together, allowing the examiner to view two objects side by side at the same time. One side shows a known sample fired from the test firearm, while the other side shows the questioned sample from the crime scene. The examiner now carefully compare the two objects, land and the group's patterns on bullets, striation marks on bullets, firing pin impressions, breech face marks, and extractor ejector marks on shells. They look for the consistent individual characteristics, tiny scratches, microscopic imperfections, or unique dents. If these features match between the known and the questioned samples, it can be concluded that the bullet or shell was fired from the specific firearm. Because each firearm leaves unique tool marks, the comparison microscope allows for highly reliable identification, providing strong evidence in criminal investigation. Overall, this video or the importance of this video is to discuss the fired bullets and cartridge cases that carry unique individual markings that reflect the mechanical characteristics of the firearm that fired them. From land and groove impressions, striations, and slippage on bullets to firing pin, breech face, extractor, ejector, chamber, and magazine marks on shells, each mark serves as a distinctive signature. By examining these tool marks under a comparison microscope, forensic experts can actually match evidence to a specific firearm. This makes ballistics evidence highly reliable and essential tool in solving crimes. In essence, every firearm leaves its fingerprint on the ammunition it fires, and understanding these marks is key to forensic investigation.